Good morning, everyone. In last video, we solved a full question paper. Nearly 10 questions we have solved it. Today, let's take up the most important questions in equilibrium. So this PowerPoint is going to give you an idea regarding both chemical equilibrium as well as ionic equilibrium. The first question for us is, yes, the acetic acid is establishing an equilibrium to form acetate ion and hydrochloric ion. The equilibrium constant may change when the acetate ion is added, acetic acid is added, catalyst is added, or the mixture is heated. So this definitely, the moment you look at this equilibrium constant is changing, you immediately think about the concept for this Lee-Chatter's principle. So according to Lee-Chatter's principle, imagine if two reactant as well as product are established in equilibrium already. They are existing so happily there. If suddenly the change exists, either the reactant side or the product side starts reacting to the strain so that it can re-establish its equilibrium very immediately. Now the question is regarding the equilibrium constant K. When will this happen? When will it change? K depends only on temperature only. So among the four options, if acetate is added or catalyst is added or acetic acid is added, no change is going to happen. But what about if a mixture is added? Yes. If the mixture is added, what happens? Temperature starts increasing. Definitely K has to change. So those who have selected this as your option, very good. Well done. Let's go to the next question. So the following isomerization reactions is 2-butene getting converted into trans-2-butene. The Kp value is provided to us. P-trans-butene is in your y-axis and P-cis-butene is in your x-axis. Which of the following is true point here? So K is called as equilibrium constant and Q is called as reaction quotient. Yeah. So analyzing it, how to get the value of the Q over here? Come on, look at this. Is it a perpendicular line that is passing through the origin here? So definitely this is related to tan angle. So with respect to tan angle, what do you know? It is opposite divided by adjacent. So what is opposite here? Trans-butene. What is adjacent here? Cis-butene. In order to know your Q value, how do you write the Q? Concentration of the product divided by the concentration of the reactant. So according to the equation, which is your product trans-2-butene, which is the reactant cis-2-butene? Yes, obviously. So what you have is very similar to this, isn't it? Yes, so can I take it the angle directly? So Q can directly be equal to tan 60 degree. Tan 60 is nothing but 1.732. The K value that is provided to us, Kp value that's provided to us, is also 1.732. So therefore, Q is equal to K is equal to 1.732. So this question is a combination of mathematical idea along with chemistry. So very good, well done, those who have got the correct answer. Let's go to the next one. In a 0.25 liter tube, dissociation of 4 moles of nitric acid is taking place. If the degree of dissociation is 10%, the value for Kp for the reaction could be. So step number 1, we have to start writing the reaction, isn't it? So nitric oxide will definitely get reduced, dissociated into nitrogen and oxygen. Let's balance it is 2N. So the volume here is 0.25 liters. And how much mole is taking place? 4 moles. And how much is the dissociation factor? 10%. So at time when T has obtained its equilibrium, what do you understand? 4 moles we have taken. Out of them, 10% of the 4 mole has got dissociated. 10% of 4 mole is nothing but 0.4. So 0.4 has got dissociated. Now look at the stoichiometric ratio between nitric oxide, nitrogen, and the oxygen. What is the ratio? 2:1. So if 0.4 has got dissociated. How much this would have got formed? 0.4 divided by 2, which is 0.2 here, and again here it is 0.22. Why? It is 1:1 proportion. So now going to write your Kp. Ma'am, what do I know about Kp? There is nothing given regarding the partial pressures and all, but we know an equation. Kp is equal to Kc RT power delta Ng. What is delta Ng? Number of moles of gaseous product minus the number of moles of reactant product. How much I have? Nitrogen, 1 mole of nitrogen plus 1 mole of oxygen minus 2 moles of nitric oxide. So which is going to be 2 minus 2, which is 0. So Kc into RT power 0, which is anything power 0 is 1. Therefore, it is Kc itself. So if you can calculate Kc here, can't we find out what is Kp? So how do you write Kp? Product concentration divided by the reactant concentration. So what is the product here? Nitrogen and oxygen. So 0.2 moles is formed per the volume 0.25 I'm just keeping it as V itself. 0.25 divided by V. Here the coefficient is 1. So raised to the power 1 divided by reactant 4 minus 0.4 divided by V power 2. Why? Because the coefficient is 2 here. So you can understand the V and V are getting cancelled over here because of its square. So what do you have here? What we have here is 0.2 square divided by 3.6 square, which is nothing but 1 by 18 square. So those who have got this as your answer, very well done, children. Let's go on for the next question. Moving for the ionic equilibrium. Select the polyprotic areneous acids from the following. So I'm going to choose very limited of these things because the rest you can do it on yourself. I'm going to give you an idea here. So polyprotic. What do you mean by the word polyprotic? So many H plus can deliver. Let me take up the first example here, H3PO2. The first law for writing any oxyacids of phosphorus is that phosphorus will be connected with double bond O. How many oxygen is still remaining? One more oxygen. How many hydrogens? We have 3 hydrogens. So one hydrogen is here, second, and the third. So remember, the hydrogen that is bonded only with OH can be clipped. So therefore, it can liberate only one H plus ion. So it is monoprotic. It is not polyprotic. Let us take up the case of oxalic acid, COOH twice. The moment you can see it, yes, oxalic acid, COOH. It has two OH here. Therefore, 2H plus can be released. Yes, it is polyprotic in nature. What about H3BO3 boric acid? So in our last video, we understood that it is not a Bronsted item, it is a Lewis acid. But the question is not regarding whether it will release or not. Does it have the capacity? Yes, it has the capacity. Boric acid, BOH, BOH, and BOH. It is having 3 OH here. So yes, 3H plus it can release. So therefore it is polyprotic. This is how you have to look for the polyproticness. Okay. Now let us look at the second one. Conjugate. Write the conjugate base of. Write the conjugate base of sulfate. What do you mean by this conjugate? But suddenly this theory is what is called as Bronsted-Lowry theory. Bronsted-Lowry theory. According to this theory, acid release H plus, base accepts H plus. So if I'm going to say an acid is there, let me say HCl is there, HCl will release H plus and Cl minus. Now this is an acid. The counterpart that is formed here is called as a conjugate. In English, what you called as a counterpart, opposite. So conjugate also takes the same meaning, opposite of it, conjugate. Since it is an acid, this opposite is a base, conjugate base. So the first one is asking you, write the conjugate acid. That means they are the bases. So let me consider sulfate as there. It is a base. Yes. So we know acid is releasing H plus. Yes, it is an acid. It releases an H plus along with the production of conjugate base. So if a base is there, it should accept an H plus. So let it accept an H plus here. So what will it form? HSO4 minus. It is a base. So what is its conjugate acid? This is its conjugate acid. Okay. Let us take the another example. Diethyl ether C2H5O C2H5. If it is going to take up the H plus, we know that this is going to have lone pair of electron. So if the lone pair of electron is going to be attracted by this, what do you have? C2H5O, C2H5 and H plus. Yes, diethyl oxonium ion it is. Okay. So this is how you have to write the conjugate acids of them or the conjugate acids of them. Okay. Let us see the next subdivision. How to write the conjugate base. How to write the conjugate base. So HNO2 is there. If it is an acid only, it will release a base, right? Conjugate base. If it is going to release an H plus, what will be the conjugate base? NO2 minus. OH minus is there. If it is releasing an H plus, what it will release? O2 minus. Correct or not? So this is the conjugate base, CB. Okay. Clear everyone? Okay, now go for the fourth one. Write the conjugate acid and base of the amphoteric species. So that means they can act as both as an acid as well as an base. So let us take up the example of ethanol, C2H5OH. C2H5OH can take up H plus. If it is taking H plus, yes, it is acting as a base. So it is going to form C2H2 and plus, correct? So this is the conjugate acid of it. The next one is asking us to find out whether it could act as an acid. Yes, of course. If it is releasing an H plus, what it will form? C2H5O minus. So this is an acid and this is the conjugate base of it. What do you call this ion? Ethoxide ion, correct? The last one. Classify the following into the Lewis acid and the Lewis base. So we know to know what is a Lewis acid and Lewis base at first. So a Lewis acid is the one which will accept the electron. A Lewis base is someone which will donate electrons. So let us take up the case of FeCl3. FeCl3, ma'am, it has a complete octet. So what will it begin? Even though it is having a complete octet, it is having the ability of having vacant orbitals. That's what. Since it is having the vacant orbitals, it will act as a Lewis acid. CH3 thrice N. Since it is having lone pair of electron, so it will act as a Lewis base. Understood? Okay, let's go on to the next question. Calculate the pH. Calculating the pH kind of question is very regularly questioned. Solution by mixing 150 ml of 0.2 molar HCl and 150 ml of 0.1 molar sodium hydroxide with 25 ml of water. Step 1. What should we do? Calculate the millimoles of HCl and NaOH. So HCl, how much you are taking? 150 ml and 0.2 molar of it. Sodium hydroxide, how much you are taking? 150 ml and 0.1 molar of it. Remember, millimoles means milli equivalence. That means it should be in normality. But we know HCl releases 1 H plus and NaOH will release 1 OH minus. Therefore, their molarity is equal to the normality. How do you calculate milli equivalence? Volume into normality. That's what we are doing here, okay? So what you have here is 150 into 0.2. Yes? Understood? So it is going to be 30 millimoles. And here 15 millimoles. So we can understand acid versus bases, they have to utilize. So when I'm going to subtract it, what you have in excess is 15 millimoles of H plus is in excess. This is an excess. So we can understand it is acidic in nature, yes, of course. But the question is to calculate the pH. Now, how do you calculate the pH? pH is equal to minus logarithm to the base 10 of H plus ion concentration, molarity it is. So what is molarity? Moles per liter. How many moles? It is 15 millimoles. So converting into moles, I have to multiply by 10 power minus 3. Yes, what divided by 1000? Both are the same. Divided by the total volume of the solution. Now, what is the total volume of the solution that I have? 150 ml of HCl 150 ml of sodium hydroxide, and 25 ml of water hydroxide. So it is 325 totally into 10 power minus 3. Why? Again, I have to provide it to you in liter quantity, isn't it? Volume should be in liter, this should be in moles. Correct. So multiplying and dividing, you will be getting the final answer for the pH. Okay. Final answer for the pH you will be getting. Understood? Understood, everyone? So your final answer would be 1.33. The final answer finally would be 1.3. Is it an acidic pH? Yes, it is acidic pH. So the answer is last one, the day. Calculate the percentage hydrolysis and the pH of 0.02 molar ammonium acetate Kb provided, Ka provided. Step 1, ma'am, pH only no. So can't I do pH is equal to minus logarithmic to the base of 0.02? No, strictly not. Why? Because it is not a strong acid or a strong base. It is a salt. I can't do that. So let us analyze the salt. CH3, COO, NH. Split it up. What you have is acetic acid and ammonium hydroxide. So this is a weak acid. This is a weak base. So this salt is currently made with weak acid and a weak base. So we need to go with the formula. What's the formula? pH is equal to off of pKw plus pKa minus pKb. So off into pKw, Kw is 10 power minus 14. So pKw will be 14 plus pKa. Ka and Kb are the same. So definitely minus logarithmic of 1.6 into 10 power minus 5 minus of minus logarithmic of 1.6 into 10 power minus 5 will definitely get cancelled, isn't it? So pH will be 7. So the first part of the question is done. What about the percentage of hydrolysis? What is hydrolysis? It is nothing but H, isn't it? So H, according to this, for weak acid versus weak base, for this salt, we need to know two equations to solve. One is KH, another is H. Okay. So KH is nothing but KW divided by Ka into Kb. So this is 10 power minus 14. And this is provided 1.6 into 10 power minus 5 square. From this we can calculate KH. What about H, madam? Square root of KH is equal to H divided by 1 minus H for weak acid versus weak base. So the KH value will be something around 10 power minus 4. I am grossly doing it. Okay. So which is definitely less. Yes, it's going to be definitely less over here. So what do we understand from the term there? If it is definitely less, what do I understand here? I could understand maybe something around 3.9. I could understand that when will this KH value will be less? Come on, let us investigate this. When will it be less? Only when this term is more. When will be this term will be more? Only when H is very less. Can you understand? KH is very less. I can understand KH is inversely proportional to 1 minus H. That means 1 minus H term should be very high. When this will be only very high? Only when H is very low. So therefore, I am neglecting 1 minus H term here. So square root of H is equal to H. So what will be H? KH square. So just 3.9 into 10 power minus 4 square. This is hydrolysis. Percentage hydrolysis, just multiply by 100. Clear, children? So in this video, we have seen the most promiscuous question that appears repeatedly in chemical equilibrium and ionic equilibrium. Thank you so much.